Okay, so let's start something called Introduction to Modular Arithmetic. So let's do a topic called Introduction to Modular Arithmetic. Um, this topic is very important in the field of cryptography. I'm going to focus this particular topic in terms of cryptography. Uh, so let's start this, and let's start by introducing some basic things that we need to know. Basically, in modular arithmetic, we're looking for uh, modular properties, which is very commonly used in cryptography and other things like that. And we're going to look at some of the operators. So always remember that cryptography uh, is done usually on positive integers. So we're only focusing on positive integers. This is what cryptography focus on positive integers, and specifically the domain that we have for z, which is for integers, is going to be n. That is going to be from 0, 1, 2, all the way up to positive infinity. These are the numbers that I'm interested in. So the first operation that I'm focusing on, we're just going to directly go to an example. So what do we have? What type of mathematical operations we have? So mathematical operations that we have in cryptography, we have plus, addition, we have subtraction, we have multiplication, and we have something called, instead of division, we have something called multiplicative inverses. Let's just call it MI for multiplicative inverses. We're going to learn that in the next tutorial, how to find multiplicative inverses of things. Multiplicative inverses, that's what we're focusing on. So let's do an example. So instead of focusing and wasting your time, let's do an example. Let's say, okay, I have given a problem which is something like this: 27 mod 5. Always remember that in mod, we are interested in remainders. We only care about remainders. That's all we care about. We only care about remainders. So what we're doing is this: we're going to divide 27. We're going to take a mod with 5. So in cryptography, we're going to call this guy which we're dividing by n, which is known as your modulus. All right. So this is in general form. This thing looks like, in general form, this looks like a mod n. So this number is going to be your modulus. In generic form, this is known as n, and this is the number that I'm dividing. So basically what you're doing is this: you're taking 27, you're dividing 27 by 5. So 25 times 5 would gives me 25, and what is the remainder that I get? Is 2. So this is going to be your remainder. All right, this is going to be your quotient, which is quotient or q, and this is going to be that number, which is a, and this is going to be your number, which is going to be n. All right, that's all I need to do in order to do modular arithmetic. So 27 mod 5, the answer of this guy is 2. Okay, let's do one more example. Let's say I have something like this: 7 mod 10. So example number 1, example 2. What is 7 mod 2? So always remember that when your modulus is bigger and the number is smaller, you get the same number back. That's all you need to remember. When you have your modulus, so the rule is this: when you have your modulus n is greater than uh, greater than, not equal to, greater than A, you get the same number. Answer is A. All right. So 7 mod 10, you'll get the same number back. So the answer for this guy is going to be 7. I hope you got this. So when you have n, which is a modulus, which is going to be greater than A, this number, you will get the same number back. That's it. Okay. Let's do one more example. Let's do example 3. Example 3, let's say I have a negative number. So let's do example 3 like this. Let's say I have a negative number, negative 18 mod 14. All right. So how am I going to solve this? So I know this guy is bigger. So we're just going to ignore the negative and we're going to treat this as a normal mod problem. So we're going to divide 18 by 14. So what is it? 14 times 1 is 14. The remainder is 4. So this is my remainder. All right. We're going to treat this as like a normal problem. And what we're going to do now, we're going to bring this out. Now I'm going to take this remainder out and I'm going to bring this negative out as well. And then I'm going to add my modulus in this number. So I'm going to add my modulus in this number. So what do I get? 14 minus 4, I'll get 10. So the answer for negative 10 mod 14 is going to be 10. I hope you got that. So what about if negative 10 mod 14? All right, how am I going to solve this? I'm going to treat this as a normal mod problem. All right, since we're only interested in cryptography or only interested in positive integers, that's all I care about. So I'm going to do 18 mod 14. I'll get a remainder of 4. Then I'll write my 4. I'll bring that negative out and I'm going to add my modulus in it. Whatever the answer I will get, that is going to be my answer. All right, let's do one more example. Example number 4. Let's say I get something like this, negative 7 mod 10. All right, I'm going to treat exactly the same way just like I have done it previously in the example number 2. Any number, so I'm going to ignore the negative. If my modulus is bigger than my number, I'm going to get the same number back. So I'll get what? 7. And I'm going to bring that negative out and I'm going to add my modulus. So my answer will be 3. So this is how you solve it. That's all you need to know regarding cryptography, modular arithmetic that we would do in our cryptography series. One thing that I want to make sure is this. One operation that I want to include is this, which is going to be a congruence operation. The symbol for congruence is actually 3 bars like this, and for equal you get 2. What congruence is that many number will map onto a particular value. All right, this is what congruence is. Many number will map into a single value. So let's look at an example. This is also one of the most common operation that we like to use in cryptography as well, which is, okay, so I have a number like this, 2 congruence 12 mod 10. Okay, so what is it that I'm doing? Ignore this 2 for right now, and let's look at this problem. What is 12 mod 10? 12 mod 10 would give me 2. Okay, but since I have a congruence operator, what congruence operator does is just not 12 mod 10 will only give you 2. What about 22 mod 10? You will also get 2. What about 32 mod 10? You will also get 2. So many values in this modulus domain would give you this number. On the other hand, equals means this value is equals to this. Okay, this value is equals to this, while in congruence many different value of your number would map into the same value. So this is one of the operations that we like to use in cryptography. So don't forget to subscribe to the channel, and I hope you like the video.